Welcome back, AgEcon. So hopefully now you feel a little bit more comfortable with how allocation tables work and how we can construct PPF curves utilizing that data. So we're going to get started with a bakery dilemma. Okay, so let's assume that Missy works at a bakery. Missy can bake 6 pans of cookies or 8 pans of brownies in an hour. Missy works for 5 hours each day. So I would like you first to create an allocation table using the template that I have over to the right. And from there, we're going to create a PPF graph. And finally, we'll select any 2 points and calculate the opportunity cost of moving along those points. Okay. So first step, create an allocation table. I've given you a nice little template over to the right. So how do you suppose you'd go about creating and figuring out how many cookies can be made and how many brownies can be made? Well, it's as simple as some plug and chug math. Okay. We know that in an hour, Missy can bake 6 pans of cookies, right? And she spends 5 hours making cookies. So what we do there in this particular example is we take 6 pans times 5 hours to get a total of 30 pans of cookies made in 5 hours. Because she's spending all of her time making cookies, however, she's unable to make any brownies. So it's 8 times 0 equals 0. So in 5 hours, if she invests all 5 hours making cookies, she will end up making 30 pans of cookies and 0 pans of brownies. Okay. Then moving on to the next one. If we spend 4 hours making cookies and 1 hour making brownies, we would take 6 times 4, which equals 24 pans of cookies, and 8 times 1, which equals 8 pans of brownies. Okay. So again, this is how much she would be producing in a total of a 5-hour shift at the bakery. And we go on and on and on until we get all the way to the bottom where we invest 0 hours of cookies and 5 hours of brownies. So we make 0 pans of cookies and 40 pans of brownies, So essentially this allocation table shows all of the different combinations of resources. We could have 5 hours of cookies, 0 hours of brownies, 4 hours of cookies, 1 hour of brownies, 3 hours of cookies, 2 hours of brownies, 2 hours of cookies, 3 hours of brownies, 1 hour of cookies, 4 hours of brownies, 0 hours of cookies, and 5 hours of brownies. Those are all of the possible combinations we could have on an hourly increment if she works for a 5-hour shift. Now, this isn't to say that we couldn't expand this to a 10-hour, 20-hour, 30-hour, et cetera, week-long shift, things like that, to describe how many she could make in a week or a couple of shifts. But this is just for the purposes of our example today. Okay, so to clean it up a little bit, this shows that without the math there, what our answers would be. So now step 2 is to create a PPF graph. So we know that we're plotting our cookies on the y-axis and our brownies on the x-axis. And these can really go any which way you want. It's just important to be consistent. So I chose to put cookies on the y-axis and brownies on the x-axis. And what I'm going to do is I'm going to go back to this allocation table and plot. So we know that on the y-axis at 5 hours, we are producing 30 cookies and 0 brownies. So I can go over here and plot point A at 30 cookies and 0 brownies right there. And we're going to go through and plot for all of these different points. And then what I'm going to do, once I've made my PPF graph, is select any 2 points and calculate the opportunity cost of moving along that curve. So I'm going to label them A through F just to keep it consistent so we know what we're talking about. And I'm going to choose the opportunity cost of moving from C to D, just like we did in the last example. So again, our formula is going to be D minus C equals our opportunity cost. And if I wanted to find the opportunity cost of D to E, I would do E minus D or F minus E, etc. We could also calculate the opportunity cost of moving multiple points. So we could have done the opportunity cost from C to E, and we would have just done formula E minus C equals opportunity cost. The biggest thing is you're subtracting the point that's farther on the right of the curve from the point that's on the lefter side of the curve. So again, at point D, we're producing 12 cookies and 24 brownies. And at point C, we're producing 18 cookies and 16 brownies. So if we do our math, that means that we are going to be losing 6 pans of cookies and gaining 8 pans of brownies by doing this. You can confirm this by thinking with your mind. That sounds kind of weird, but like looking at this graph and visualizing it. Okay, if we move from C to D, we're going down in our cookies and we're moving across in our brownies. So that makes sense because we are gaining brownies and we are losing cookies. Okay, so our math is correct. It makes sense. And that is how you do all 3 of these steps together. So the next set is going to challenge you to do all of this on your own, and we'll see how you do. Thanks for watching.